Hi, this is Liji from Prog Easy, and I'm starting a new tutorial series on statistics for data science. In this series, I'll be covering all the statistical concepts which are required for basic ML and DL algorithms. So, without much delay, let me start. And today we'll be doing some basics of statistics, and in the further tutorials, we'll be going much deeper into this statistics for data science. So, what is statistics? So statistics, it's a science of collecting, organizing, and analyzing data to derive some meaningful information. Okay, so it is basically it's a science of how we can collect data, how we can organize data, how we can analyze data, and for what, how to derive some meaningful conclusion. So why do we need statistics? So it helps us to derive some new meaningful information from raw data. Okay, that is one thing. It serves as a comparison tool. So if there are some multiple that are available to us, how these data relate to each other. So it serves as a comparison tool. It can quantify the uncertainty. Something like, okay, we are telling like, okay, there is a chance that some event can occur. So what is this chance? It is an uncertainty that we are mentioning over there, right? Using statistics, we can quantify it. We can say that there is a 95% chance that some event can occur. Okay, so this is what is meant by it can quantify the uncertainty. And the last is it recognizes patterns in the data that we are having. Okay, so these are the some useful parameters of statistics which helps us in deriving some meaningful conclusion from the data that we are having. Now, when we are speaking about statistics, we have to understand few terms. So one is population data and sample data. So suppose you are having a data, and if the data is of an entire group, okay, from which you want to draw conclusion, then it is known as the population data. So if you see over here, this is the entire group that is available, right? This is the group. So if the data is pertaining to this entire group, then we can say that yes, I am having the population data. Okay, but if you are selecting some few random samples from this group, and we are deriving some meaningful information, we are deriving some reference from it. Okay, then it is known as a sample data. So it is a specific group from which we can collect the data. Okay, so population data refers to a large group of data, and sample data refers to a subset of it basically. Okay, now moving ahead. So while we are referring to this population data and sample data, there are the meanings. There are some meanings that is attached to the symbols. So basically, if you see the capital N refers to the sample size of a population data, and small n refers to the sample size of a sample data. Okay, so if we are mentioning like, okay, the population size is of 1000, and we selected a sample data from it which is of size 10, then the capital N will denote 1000, and the sample small n will denote 10. Okay, now when we are finding mean, okay, the average from the population data, it is represented using mu symbol. Okay, and the standard mean of the sample data is represented using x bar. Okay, similarly, standard deviation of population data is referred using sigma, the symbol sigma, and the standard deviation of sample data is referred using the symbol yes. Okay, and variance, as we were aware, it is the square of standard deviation. So variance is referred as sigma square, and the standard deviation of sample thing is referred to as yes square. Okay, in detail we'll see in later in today's tutorial, we'll see the details of what is mean, standard deviations, and variance, etc. But as of now, we should be understanding the meaning of these symbols. Okay, now going ahead, there are the statistics can be of two types. Okay, so one is descriptive statistics and other is inferential statistics. Descriptive statistics is when we have a certain data set, and from this certain data set, if we are able to find some meaningful information like what is the average weight, what is the standard deviation from the weight, from the average weight, or what is the maximum weight. Okay, like this kind of descriptive. If we have a certain set of data, say I will just write it. We have a certain set of data like 1 2 3, again we have 1 4 5. Okay, like this. Suppose this is the data that we are having. Okay, if we want to from this we can find the average, we can find the maximum value, we can find the minimum value. So it gives a description of this kind of data that we are having over here, right? So this is known as a descriptive data. Okay, so it gives a meaningful summary of the data that we are having. Okay, and in case of inferential statistics, it gives us to come to a meaningful conclusion, okay, from a sample data we are having. Okay, so suppose we are having a sample data like this. Okay, we are having a sample data like this, and with the sample data, if we are able to come to a meaningful conclusion on the population data, okay, some meaningful conclusion on the population data, then it is known as, yeah, then it is known as inferential statistics. That kind of statistics is known as inferential statistics. So whatever data we are having of the sample data, from that if you are conclude something about the population data, then such kind of things is known as inferential statistics. For example, if you see over here, exit poll. So when an exit poll, when an election happens, okay, suppose election happens, that day itself the news channels comes up with the who is a probable party to win that election. Okay, how they do it? They are not going to entire population and getting the data, right? They are selecting a sample set of people, okay, some random people from the population, and then they are coming up with some values from them, okay, some details from them, and based on that they are coming about with the population and their value for the entire population. So this kind of data that we can obtain from the sample population is known as inferential statistics. Okay, now let us see how what are the few descriptive statistics things that is available to us. Okay, so some of the some summaries that we can get from the descriptive statistics is, first is measures of central tendency, then there is measures of spread, then there is measures of shape. Okay, so I'll just say, suppose this is the distribution that we are having. Okay, this is the distribution that we are having. Okay, so measures of central tendency will give where the central value of this distribution lies. Okay, so this is the measures of central tendency will give that this part. Okay, now measures of spread will give how far this data is spread. Okay, the spread of the information about the spread of this data is given by measures of spread, and the measures of shapes gives the indication on the shape of the distribution, how the graph will come up. Okay, it can be like this, it can be somewhat like this, it can be somewhat like this. So this measures of shape will gives us indication about what kind of graph distribution we are having at hand with the data set that we currently have. Okay, so now let us see measures of central tendency in more detail. So measures of central tendency is a value that attempts to describe a set of data by identifying the central position within that set of data. So there are three main measures of central tendency, that is the mode, the median, and the mean. Okay, so these are the three main measures of central tendency that we have. Okay, now coming to mean, what is mean? Mean is the mathematical average of a set of two or more numbers. So suppose you have a set of numbers, mean is the mathematical average of those numbers. So what is average? We all know that it is sum of all data points divided by the number of data points, right? So here I am having an example. I am having some data over here, 15, 10, 19, 7, 11, 15, like this one data is there. Now how to find the data? We have to find the sum of all numbers. So it will be 15 plus 10 plus 19 plus 19 plus 7 plus 11 plus 15 plus 19 plus 20 plus 12 plus 17 plus 18, which is 182. Now, how many numbers are there? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 numbers. So, sum of the numbers by number of numbers and whatever we are getting over here. Okay, so the mean here is 15.17. So, this is the mean that we have it over here. So, mean is basically the mathematical average. Okay, this is how we calculate the mean. That we need to understand how we can calculate the mean. But in case of Python, we don't have to go about doing this calculation. What you can do is you have to import the NumPy library, import NumPy as NP, then np.mean, and you have to pass the data set. Whatever you are having, it will give us the mean. Okay, whatever is there, it will give us the mean. Okay, so this is the numbers, some random set of numbers I have given over there, and I have got the output as 6. Okay, now there is another kind of central tendency that is known as median. Okay, median represents the middle value of any group. It is the point that so suppose we have some values like 1, 2, 3. Okay, so this here we have some values like this value. Okay, this median refers to this value. Okay, it is the point at which half the data is more. So this will be the half the data will be more and the half the data will be less. So this point is known as the median. Okay, so in order to calculate the median, what we'll have to do is we'll have to arrange the observations in ascending or descending order. It doesn't matter which order we are arranging. Only thing is that we have to arrange it in ascending or descending order. Okay, and now if the number of observation is odd, we will be having a clear cut middle value over there, right? See, here the number of observation is odd, so we have a clear cut middle value of over here. Okay, so the median will be n plus 1 by 2th value. So here there are 7 values. 7 plus 1 is 8, 8 by 2 is 4. So the fourth value gives the median. In case this is a odd number, so suppose I am having one more thing over here, then the middle value will be, these two will be the middle value, right? Now in order to find the middle value of median in case of even number of observations, what we'll have to do, we'll have to find the average of these two values. Okay, so how do we find average? It is like we add both the things and then we divide it by 2, right? So that is what is going to find the value at n by 2th position. So this is n by 2th position, and the find the value at n plus 1 by 2th position. Okay, and then we have to get the average of these two values. So median, main thing we have to remember is that we have to arrange all the observations in ascending order. Then we have to go and find the middle value. If it is odd, we'll directly get the middle value. We can just take it as it is for the median. And if it is even, we'll have to find the average of middle two values, and we'll have to come up with the median in that case. Now going ahead, suppose this is a set of data that we are having 1, 3, 3, 6, 7, 8, 9. So the middle value, it is clearly evident that 6 is the middle value, right? There are 3 observations to the right which is greater than this, and 3 observations to the left which is less than this. So the median is 6. Okay, in this case, there are the middlemost two values, because the number of observations is even, the middle values are 4 and 5. So there are 3 observations to the right and 3 observations to the left. But in order to get a middle value, since it is an even number, both of these fall in the middle position, right? So we have to take the average of these two, that is 4 plus 5 divided by 2 we will have to do, and then we will be getting the value. See, 4.5 is the median in this case. This again we can do mathematically using Python. So this is np.median. We'll get the value. Okay, so np.median. So the first data set I passed and I got the value as 6, and the second data set I passed and I got the value as 4.5. So again we are using the NumPy library over here to find the median. Okay, now coming to mode. Mode is the data point that is having the maximum frequency, or the data point that is repeated the most. So if you see over here, 9 is repeated 3 times, right? There is 9 over here, there is 9 over here, and there is 9 over here, right? So all other data is used only once, and 9 is repeated 3 times. So the mode is 9. Okay, now again, in order to find the mode, here in the NP diary, the NumPy library doesn't supply as a function to calculate the mode. So we'll have to use the statistics library over here. Then statistics.mode, of, and then we pass the data set, we'll get the mode. Okay, so in case of measures of central tendency, we have three things, which is mean, then we have median, and then we have the mode. Now let us see the measures of spread, that is measures of dispersion, which means that how much the data is dispersed. So suppose we have a distribution like this. Okay, so this, how much the data is dispersed. Okay, that is how what we can know from this. Okay, so there are many ways by which we can find the dispersion, or means the measures of spread also, range, standard deviation, variance, interquartile range, and then z-score. Okay, so range is nothing but the difference between the highest value and the lowest value. Okay, so here there we have some big ages of students are mentioned over here. So if you see, the highest value is 16 and the lowest value is 30. It is not necessary that we have to arrange it in ascending order. You just have to find the highest value and the lowest value, that will do. So the range is 3. Okay, so the range within which the all the values of the students are lying is just 3. So it just so this 3 indicates the spread, how much the value is spread. So we will come to know that, see, if you have something like this, 14 to 16. Okay, so this is the range within which the entire values are coming. Okay, now coming to standard deviation. So standard deviation is a statistic that measures the dispersion of data set relative to its mean. Okay, so basically what standard deviation does is, it checks, we have suppose we have a set of data. Okay, it checks how each of this data is, how this data is dispersed from the mean. From the mean, how far is this set of data? That is what we calculate using standard deviation. Okay, so standard deviation is square root of variance. So variance is again the measures of dispersion variance will give, and once we take the square root of it, we get the standard deviation. More the spread of the data, the higher the standard deviation. That I will show with this example. So if you take over here in the first one, which is blue line, the standard deviation is 5. Okay, so if you see over there, entire data is spread in this region. Okay, this region, see, like this, entire data is lying with this. Okay, the now standard deviation is less, means the spread is less. Okay, now if you take this standard deviation 10, the data is spread over a larger area, like so. The more that standard deviation, the larger is spread. And in the third one, the standard deviation is 20 and the spread is more. So if you come to know that the higher the standard deviation, you will come to know that the spread is more, and lower the standard deviation, which means that the spread is less. Okay, now let us see how the calculation is done. In case of, first we'll see how variance is calculated. In case of population data, we have to take everything with respect to population. Okay, so this is one individual data HI minus mu, that is average. This is what I told earlier. We'll be calculating the deviation of a value from its average, and we'll find the square of it, then divided by the number of data items. Okay, so we are finding the HI minus mu is again the population mean, square of it divided by n, which is the number of data points in that population. This is variance, and standard deviation is just a square of it. Yeah. Now when we compare do the sample data, when we do it for sample data, the difference is that we'll be using all the sample data data average. See, this is x bar, which is sample data mean. Then we are using n, which is sample data number of observations. But another difference is that we'll be using n minus 1 over here instead of n. Okay, so that is another difference in case of sample data. So again, the variance is found out by using sigma 1 to n. So this is done for all the observations, right? How much the one observation is deviating from the mean, we are finding out. Then we are doing a square of it, and then we are dividing it by n minus 1, that is the number of sample data minus 1. So why this n minus 1 will be covered later in the later tutorials that is going to come. So this is so you should be understanding what exactly is variance, and what is the meaning of variance, and what is the meaning of standard deviation. deviation. So at a later of point of time, when we have to derive some meaningful information from the data that we have, then you should be understanding the concept behind it. You need not have to calculate all these things manually, because again Python gives us functions and methods using which we can calculate all these things, but understanding what it is and how it is and things that we should be knowing. Okay, so again, in order to find the standard deviation of the data, we just have to call np dot std. Okay, std is the function with which you can calculate the standard deviation of a data. And var is another function with which we can calculate the variance of the data set. Okay, now, so this is another means of finding how far, how the spread, how much is the spread. We can find it using standard deviation or variance. Like, so if we have a data over here, and if it is 1 sd from this is the mean, and if it is here, okay, it means that it is 1 sd from here. Okay, if it is from again over here somewhere, that is 1 sd, then 2 sd, then we can say that yes, it is 2 sd from here. Like that, we'll be able to find the measure of spread from the standard deviation and variance. Now, quartile range. So this is a method by which you can find the dispersion from the median. In case of standard deviation, we were finding the dispersion from the mean, but in case of interquartile range, we are finding the dispersion from the median. Okay, now suppose you have a data set, arrange it in ascending order. You will be having the median, that is a middle value, right? Now, from the middle value, you will have two portions like this, right? There is one portion in which all the values are higher, and there is another portion in which all the values are lower, right? Now, if you find the mid value over here, then you will get the quartile 3, that is Q3. Now, if you find the mid value over here, you will get the quartile 1. And the difference between quartile 3 and quartile 1 will give us the IQR or interquartile range. So this is why I told this is how you can find the spread with respect to median. In case of standard deviation, we are finding the spread with respect to mean. So mainly this is the spread of middle 50% data. Okay, so quartile Q3 means it is 25% from here, or if you take it from here, if this is 0%, this is 25%, this is 50%, so this is 75%, right? So Q3 is 75% value, and Q1 is 25% value. Okay, so difference between these two gives the interquartile range. Now coming here, so here I am having an example. Here again things are arranged in ascending order. So if you see, the middle value is over here, that is 71. From 71 we can divide it into two half, that is upper half and the lower half. Now again the median of this half, okay, which will gives us 77, that is quartile 3, and the median of this lower half is given as 64, which is quartile 1. Difference between this Q3 and Q1, which gives us 13. Okay, so here it is 13. So the interquartile range is 13. So this is another way by which you can find the measure of spread. And more of these quartiles of percentiles will be covered in later tutorials, that I will be uploading. Now coming to z-score. Z-score is measured in terms of standard deviation from mean. So suppose this is the standard deviation, this is the graph that you are having. Here you have the mean. Then if you come here, this is mean, this is 1 SD, and the value this is 2 SD, and this is 3 SD. Okay, now if you consider this mean as 0, the value that is coming over here will be having a z-score of 1. Value will be coming over here will be having a z-score of 2. Value that is coming will be having a z-score of 3. So that is how much SD a value is from the mean. That is what is meant by z-score. Suppose I am having a value over here. I can say it is somewhat 1.25 or 1.3 SD from the mean. Okay, so this is another way by which you can find out the spread of the dispersion that we have. And this again, more on z-score will also be covered later in the upcoming tutorials. So in case of finding that kind of dispersion, means spread, measures of spread, we have range, which is highest value minus lowest value. Then we have standard deviation and variance, which is with respect to mean we are finding the spread. Then we have quartile range, which with respect to medium we are finding the spread over here. Then we have z score, which is again based on standard deviation, but one z score gives us how much standard deviation a value is from the mean. Okay, so with this, it's me Liji signing off. I'll be back with more tutorials on statistics. If you like this video, do add your feedback as comments, which will encourage me to create more such videos. Also, do subscribe to this channel so that you don't miss out on other tutorial videos. Thank you and catch you later. Thank you all.